So let's talk about RPGs. They are, without a doubt, one of the most popular game genres of all time, as I can personally tell. And what I like the most about RPGs is that they're relatively easy to create, with all of them having one thing in common, which at the same time is also their most important mechanic, which is nothing less than the player. So first, what we need to do is adding the player GameObject itself, and in order to do that, we can simply use an empty GameObject and call it player, so the name is self-explanatory, and doing it is as simply as clicking right and then selecting your respective item within the hierarchy. And in case you're a beginner, most of those game objects are also going to be those very objects you can find in your finished game later on. If you want my personal help on this, please feel free to join my premium course. Next, if you can see in the inspector there are any components attached to your player game object, make sure to remove them, except for the sprite renderer, in case you want to make your player character the same style like me, which is like this player style you know and love from Paper Mario. And as the name suggests, this very component is gonna render a single sprite, so a two-dimensional surface, if you will, containing a texture right within your Unity project. And in case you got some awesome sprites sitting in your project already, please feel free to just add them to your sprite renderer by dragging and dropping them into the sprite field. Next, I wanted to change its position and scale a bit by hitting W or R, I think it is, and then using the mouse to position or scale it. And since I initially felt it was a bit off, having that sprite floating just in the air, I also added a shadow to it by just adding yet another sprite and placing it right below the player, heading up and making it very dark by changing the color attribute from its respective sprite renderer. And even though you can tell it's not the prettiest one of all, I felt like it was fastest to just use the standard knobs right here, and later on also made it slightly transparent, again by using the color field from the sprite renderer. And since, as far as I'm concerned, there is no RPG where the player falls right to the ground, so that's why we also want to add a collider to it. And in my case, I found it was the easiest to just use a box collider here, whose borders you can simply drag so you feel like it fits your player, finishing those components off by adding a rigid body to it too, which is Unity's component, which is characteristic for enabling physics, like gravity and such. So now that we got our player object up and running, let's continue by creating our very first script by clicking right and then choosing create and C# script, which we can then already attach to the player too to add its behavior to it that you're gonna code with me over the course of this video. So buckle up, and then let's open our player script by double clicking on it. However, before starting to code, you might have realized that some RPGs, like I believe the old Final Fantasy games do it, have a distinct player for the game's overworld. So if you want to add a similar one to this too, I would encourage you to use a whole nother game object for that, and also a whole nother script, as your overworld player's control is most likely differ from your original one, as in most cases it's just a sprite moving across the map without the ability to jump or to attack whatsoever. You can always feel free to ask me for my personal help on it on my premium Discord. So, what mechanic of the player we could start with? Well, at that point, it's only a floating sprite, so how about adding its basic movement first? And what I like to do with new scripts is clearing things up by removing all of its methods and also those unnecessary usings right at the very top. Now, to be able to move the player, we want to be able to change one important variable within Unity's inspector, which is the player's speed, and we can tell Unity our player should have this attribute to it by writing public float, because we don't only want it to be an integer, and then just use speed here, so it's self-explanatory again. Now, as you can see, you're already able to use your speed variable and input any value into it, like 2, and that's it. However, Unity doesn't yet know what to do with that value, so that's what we want to teach Unity next. And if you think about it, moving the player has definitely something to do with manipulating its physics, like its velocity. So the component we need to ask in order to do that is our rigid body. And the way we can tell Unity through the script we want to do something with the rigid body component is by typing rigid body at the very top, and then opening the awake method you can see right here, which you can think of as some kind of micro program or code snippet, which is being executed automatically at the very start of the game or even before it. This is where we want to assign the rigid body handle we got within our code to the actual component within Unity, which you can do by typing in rigid body equals and then get component rigid body. Again, all of this is not going to make our player move, unfortunately, so that is why we want to open yet another method, which is the fixed update method, which is getting called continuously, and I'd encourage you to use it for all things related to the user's input, for the user's inputs, movement. And right in there, we want to ask the player's rigid body component to add a velocity to it. In other words, to make the player move. And the easiest way and safest way to do that is by just assigning a value to the rigid body by using rigid body.velocity and then assigning a new vector3 to it, which is just a data type containing three different attributes called x, y, z. As you might have guessed, this one is predestined to become to be used for positions and vectors and stuff. And as you can see, I'm going with the notation here of telling the attribute you want to assign within the definition, although you don't have to write x colon, y colon, and z colon here, but I feel like it's easier for you then. Then the y component, or the y value, we don't want to change at all here, so make sure to use the value it already has by using rigid body.velocity.y here, and you never ever use 0 here, as it would cancel out our jump later on, as we're about to apply a vertical force there, and by setting it to 0 again, we would eliminate it basically. Then for x and z, we want to be using input.getAxis, horizontal or vertical respectively, which will make the x and z value depend on the player input, which on the keyboard is like A and D for horizontal and W and S for vertical. And the reason why we're using getAxis here is because we want the movement to have a smooth start and beginning, as this will either be 0 in case the player is not doing any input at all, or anything from 0 to 1 with 1 included, depending on how long the player presses the respective key or how hard the player pushes the stick on the controller. And also, please make sure to not be like an imbecile like me here, and make sure to somehow include your speed variable we actually created for that very purpose within here by multiplying the horizontal and vertical input with speed, so that it actually has an effect on the player's movement. And as you can see, well, our player seems to be somewhat moving, however, the player is also falling right to the ground, and it's all in all behaving in a strange way. And the reason for that is because our rigid body component, which I told you is characteristic for a GameObject's physics, is actually doing more here than it should, and we can restrict it from manipulating the player's rotation by expanding constraints and then locking all kinds of rotation. So feel free to take a look at what you got now, and voila, the player's movement seems to be working. Nonetheless, an RPG with a fixed camera does still feel somewhat awkward, and within Unity, making the camera follow the player is as easy as just changing its position and rotation beforehand, and then simply attaching the camera GameObject as a child GameObject to your player GameObject, causing all of the player's children to move alongside with it, which is also why the shadow works actually. However, if you're using a 3D model for the player, please make sure to rotate not the entire player object, and instead only the game object the model is attached to avoid rotating the whole camera with it. Again, you know where to find me. And not sure what you think, but I think this feels a whole lot better now, although we're still missing animations, obviously. And I'm just realizing my demo world behaves a bit awkward by not having any colliders to those walls, but to the grass for some reason. Anyway, but before doing that, as far as I'm concerned, most of modern day RPGs also let the player jump, and the way you can add a jumping feature to your player is by adding a few more lines of code to your fixed update method, for instance. And in case like you don't feel like extracting your different lines of code here, I'd like to ask you to at least add some comments as I'm doing right here, so you know what snippet of code is doing what. And one thing we do not want to do is to have the player jump infinitely, or like continuously, so we somehow need to find out whether the user actually wants to jump, which is by just checking the input. So make sure to use an if statement here, and then asking for input.getButtonDown with jump as a string, which on desktop refers to space, which I think is fairly intuitive. And not sure if you realized, but using just get button here does also work, or at least it looks like it, because what this is going to do then is, as long as the user is holding down the space key, it will continuously asking our player script to jump, resulting in an infinite jump. However, what we want to do is per hit of the spacebar, asking the script for only one single jump action, so we can make sure we only execute the following code within the very first frame of our input by using getButtonDown. Just so you know, like a few minutes ago, jumping obviously has something to do with our physics or rigid body component respectively, and the easiest way to implement it is by calling rigidBody.addForce, and then we need to pass in some information, like the direction we want to apply the force to, which is obviously to the upside, and hence we want to be able to manipulate the player's jump force at any time. We again want to multiply it with our very own variable, which I'm going to call jump here, and then the last we need to do is telling Unity what kind of force we want to hit, which is obviously not a continuous one. Instead we want to have one impulse, and that's why I'd ask you to type in force mode.impulse as the second parameter. Our jump variable, however, we can add right below the speed one, which I'd encourage you to use a float again for. So how does our executed result look like? Well, not too bad, except for one thing. We're still able to jump infinitely. And why is that? Because we do not restrict the user from just spamming space and thus firing like 100 jump prompts at once. So with that you can see that we actually took one thing for granted we actually can't, which is we forgot about telling Unity that objects or characters should only be able to jump as long as they're on the ground, except obviously you want to add a double jump. And the best way to do that is by shooting what's called a ray, which in Unity is an visible object still being able to interact with its surroundings on a physical layer, and thus being able to detect collisions without the user noticing. That would be very annoying. And you can add this additional check by adding a new function, the isGrounded function, or you can obviously name it however you want, which is gonna paste or return a value, a boolean, so yes or no, to the point it has been executed from. So besides our input, we want to add an additional condition, which we do by using this AND sign twice, and then calling our very own isGrounded function. And inside the thing, we want to shoot our array by calling physics.raycast, and then the first information we need to pass in should be the starting point, in our case the player's position, referenced to by transform.position. Then we need to have information about the array's direction, which should be to the downside, and then we want to store the result, whether an object has been hit or not, within a new variable called hit by using outHit, or you can also declare it right in there by using out regashit.hit. And our fourth and final attribute or argument is gonna be the race maximum distance, which I was using half of the player's Y scale in the beginning, plus something very small. However, what I figured out worked best was adding a custom height variable here and dividing that by 2 plus something small enough. This new variable we obviously need to add at the very top here again ourselves. However, if we return true right away here, meaning the player is grounded as long as what we typed in above is met, we would still encounter another issue, which is the player would still think he's grounded at any point because we didn't tell Unity the ray shouldn't stop at the player. So if we start at the player and shoot away, the ray would still hit a collider, which is the player wants itself, obviously. So in order to prevent that, we also need to check whether the object hit doesn't have a tag player to it, or the tag. More accurately, is in Unity you're able to add a single tag to all of your game objects through the inspector, as you can see right here. So let's fire up the thing again, shall we? And from what it seems like, everything is working the way it should. Awesome. One more thing I got on my list though, and those are the player's animations, which, believe me, are going to make everything just feel incredibly more authentic and good. Or engaging was the word, engaging. And when it comes to animations, I'm happy to tell you that Unity has its very own state machine to it. We can use it to implement our animations very easily, which we can access by going to Window in the top navigation bar, I think it's called, and then adding animation and the animator. The animation tab being the editor for each and every animation itself, and the animator being the state machine, with one state representing one animation, as you might have thought. Thus, make sure to add a folder for your animations, and then feel free to add an animation called player idle, whatever you feel most comfortable with. And as you can see within the animator tab, Unity does always interpret the first or the only animation as the default state. It will automatically create a transition to being the initial one. And right here, if you're creating a player with a 3D mesh, you can hit onto the red circle and apply your changes like right away yourself, as you might have known from Blender and modeling or animation software called automatic keyframes. However, since I personally am using a sprite character here, I'm just able to select all sprites from my respective sprite sheet, referring to the idle animation, and just dragging them right in here. However, since those guys are pretty close to each other right now, the animation is going to be very quickly too, so I thought best by changing the speed within the animator's state to 0.1 here. And if I now execute the thing once more here, you can see that thing looks like it's working now. Good. So now you're able to add your player's walk or run function too, by again opening the respective dropdown and clicking New Animation. And just like with the idle one, the way I'm able to do it is by just adding all those sprites here. Unfortunately, if you execute your game once more, you'll see that at least so far, Unity doesn't have any reason to assume we want to change any of those active states. So what you need to make sure to do now is adding a transition from your idle state to your walk state. And since we don't want our state machine to go that very transition right away, we also want to switch the subtab to parameters and add a new boolean called working or running to specify what logical state the player finds himself in, and depending on the working bool, like whether it's true or false, going the respective transition within the state machine or the animator. And that you can do by simply select the transition and adding a new condition, which should be the working boolean, and then whatever value you want it to have. For moving from idle to walk, it should be true, and vice versa, it should be false, obviously. Trying it out now still wouldn't give you the results you're looking for, because now we got that boolean giving us the required information on one hand, but on the other hand, we don't even change it at any point, so we still need to make sure, like from our code, to tell the animator what logical state we find ourselves in by changing the respective boolean within the code. So add a new comment here if you feel like it, and then the way you should be doing it is by checking whether the player's velocity, like using rigidBody.velocity, whether the player's x velocity or z velocity is not equal to 0, meaning the player is moving on at least either of those sides, or at least one of those sides, then this entire statement turns out to be true, because we're using an OR here, like by using those two lines here, and then calling animator.setBool, your name of your boolean, which was most likely walking or running, and then we want to set it to true. And don't forget to ensure you actually got access to your animator component by doing it the same way like the rigid body one. Oh, I think with the rigid body one, you should also be putting a new in front of it, and you should assign the actual animator component to the animator variable by using get component again. However, by doing it like this, you also need to make at least a branch of this condition to set the boolean for running big to false. So there's an even easier way to do that, and that is by putting the entire condition right into where we got true before, as every condition is still a boolean statement, meaning it's gonna be evaluated as true or false anyway, so we got it in there right away. And if you were following me closely, you might have noticed I didn't told you to add is grounded to the same condition, which is because it was breaking my neck later on. So do yourself a favor and leave that those third subcondition with is grounded. Just drop it. If you were to try it out right now, you would realize it would still feel pretty awkward, considering your inputs, because all of our conditions, all of our transitions, you still have an exit time to it, meaning in the worst case, it might take, like 1 second or whatever, after you stop pressing your key until the player is stopping to move. And the best way to fix it is by just unchecking the has exit time box in all of your transitions. And unfortunately, I do not have a second camera for my hands, unlike some girls do. So unfortunately, I can't show you like how much better it feels now. But I can tell you it does. What still feels a bit off though is our player is always heading to the right side, no matter the direction we go. So how about just flipping the player sprite whenever we realize our player or our user wants the player to be moving to the left, and as it turns out, that is as easy as creating access to the sprite renderer the way I told you earlier, and then near your animation code accessing the sprite renderer and setting flipX to, we don't know whether to set it to true or false yet, but again, the easiest way to do that is by just putting the condition right after that, which in our case we want to flip the x-axis in case the player's velocity on the x-axis is smaller than 0, meaning the player is heading to the left. And now, although it always feels a bit strange to see your flipped sprite for the first time, I can tell you your players are gonna love that. Just take a look at how much more authentic it feels now. The only thing not feeling authentic right now, though, is the player's jump, as we're still playing the walk animation when jumping. So let's make sure that mechanic is covered within a nice little animation too. Add a new animation to your player and call it like player jump, and then simply set your keyframes, or in my case, as I had to realize it actually was just a single sprite. So this time I was just dragging a single sprite here. Well, well, it's better than nothing, I suppose. Then don't forget to teach your animator, State Machine, about the transitions you'd expect when thinking yourself into the position of your players, or the user. So this time, add a new trigger, which basically acts like a boolean, but only like once. So as soon as you fire the trigger, it will stay true until the animation has been, or the transition has been going by the state machine, and then it will automatically return back to its idle state, which is false, equivalent to false. Then add a transition both from the idle state to the jump state and from the walk state to the jump state, and make both of those transitions fire as soon as the trigger is firing by adding it to the conditions list. And you can also tell it doesn't require any further specification of its value, as it's practically one valued. Nonetheless, trying it out now would still lead to nothing, as we again need to fire the trigger manually from our code, which we can do by adding the command to line 50. So within the jump scope, it's only being executed if the player indeed is allowed to perform a jump. And this time around, again, instead of using setBoolean or setBool, we're using setTrigger here with the name of our trigger jumping without adding any further value. Also, you can always reset triggers funnily by using, I think it's resetTrigger, in case you changed your mind before the frame passed. Sadly, well, not for the player, but for the player, we've now successfully frozen our player GameObject to remain within the jumping state for eternity, because we didn't add the transition the other way around. So make sure to add a transition from your jumping state to your idle state, and also from jump to walk, so we get this like kind of triangle. And now our challenge is to tell whether the player is grounded, as we do not want to return to either one of those two states before we're actually grounded. And you can do that either by scrapping the jumping trigger and making it a boolean, or by adding yet another boolean for is grounded, in case you want to discriminate between actually jumping and just being in the air without jumping, like in case you're falling. Then you should go with this approach here. Finally, make your jump to idle transition so that it fires when walking is false, but is grounded is true, and the other one should fire whenever walking is true, as it's the walking one, and it's grounded as well. And here you can see me fixing the issue we were talking about earlier, like an idiot. Oh, and make sure to set your isGrounded boolean here too, and in order to receive the respective value, we made a function for that earlier, so just feel free to call it here and pass its return value right to the animator. And now just take a look at how smoothly we're able to make the player jump, playing the respective animation, just like a young kid who had just figured out he's able to jump and separate himself from the world he has been pulled towards over the course of the last years. Now finally I want to show you something you're probably gonna love me for, and that is I want to quickly point out towards 2D rigging, which is a technique similar to 3D rigging, which allows you to add what's called bones or a skeleton to your 2D sprites. I mean, it's third party, but causing any movement of those bones during runtime to make this your player sprite follow alongside with it, which might be very useful to you in case you plan to have like very beautiful animations like with Hollow Knight or whatever, and you do not feel like creating like 60 sprites per second. Then you can simply add your bones to it and make those move instead. You save yourself some time. Another mechanic some players within RPGs have is being able to perform an attack on the overworld too, or like in this form, causing any battles to be entered with a I think first strike it's called mostly, If you want to implement that too, I would encourage you to just play an animation and then like shooting one or multiple rays like to the side, and in case it hits an object which is tagged an enemy, initializing the battle with a flag set to true. Then the only thing I can tell you is whenever you feel like you need help with any of this, or you want to have my personal assistance when it comes to implementing any of those features I was just pointing out to you, feel free to join my premium Discord and just ask me. And hopefully you can find it on my Patreon within the description. Not sure if you know, but YouTube just added an A/B testing feature for thumbnails finally. So feel free to tell me in the comments which one of those you received. If you want to learn Unity by recreating Minecraft within Unity, there's a video on my channel for that too. And hopefully I see you there, and happy programming.